So f from R to R be a function defined as f of x is 2 minus e power x minus 1. And we are given that capital F of x is 0 to x f of t dt. So what does that mean? F of x is 0 to x f of t dt, that is 2 minus e power t minus 1 dt. Integrating, what we will get? 2t minus e power t minus 1, t running from 0 to x. 2x minus e power x minus 1 minus 2 times 0 minus e power 0 minus 1. So this would be 1 by e plus 2x minus e power x minus 1. Also f dash of x is 2 minus e power minus x minus 1, 2 minus e power x minus 1, that is f of x. Now this is given that f of x is defined for x greater than 0, for x greater than 0. Then pick the correct option. Small f of x has local minimum at x equal to 1. How do we see that? We have to compute f dash of x, that is d by dx of 2 minus e power x minus 1, which is simply minus e power x minus 1. Okay. Now, is this 0 anytime? No. So we can rule out a local minimum or local maximum. So we can rule out a maximum or minimum for this. Even if there is a local minimum also, your f dash x should be 0. Okay. F of x has a local minimum yet x equal to 1 plus log 2 base e. How do we do that? See that we see f dash x. What is f dash x? Is simply f of x, that is equal to 0. X is 1 plus log 2 to the base e. Now, so there is an extremum at this point. We want to check whether it is a local minimum or a local maximum. How do we do that? We do that by finding out what is the double derivative of x, and also see that this is more than 0. So it is defined. We are given x is greater than 0 for f of x to be defined. F double dash x is f dash of x, that is minus e power x minus 1. Minus e power x minus 1 turns out to be that is minus 2, which is less than 0. So if at all it is a an extremum, this point for capital F of x, it is a local maximum. So this is wrong, this is wrong. F of x has no local maximum. We just found out that this is local maximum, so this is wrong, right? So these three are wrong, then this should be correct. Let us see. F of x has no local maximum. This is tricky because f of x asymptotically reaches 2. Let us see how it looks like. Because small f of x derivative is not 0, is never 0 except when x tends to minus infinity, right? So let us see how it looks like, the graph of this. How does e power x looks like? E power x looks like this. E power x minus 1. This is y equal to e power x. So e power x minus 1, it will look like this. I'll use the next page. E power x looks like this. Okay. How does e power x minus 1 look? It, y equal to e power x equals to 0, y equal to 1. E power x minus 1, I'm sorry, this does not look like this. It looks like this, right? At x equals to 0, it would be smaller. This would be e power minus 1. So this shifted by 1. How does y equals to minus e power x minus 1 look? Right? So minus e power x minus 1, it will just be the mirror image about y equals to 0. So it will be like this. And this is right. And then you have y equals to 2 minus e power x minus 1. So you are basically adding 2 to every number in this. So 2. So it should look like this. I hope I'm correct. Right? No. So this is actually a continuously decreasing function. So it should not have a local maximum also. It is asymptotically reaching this. X is equal to uh, this is it is asymptotically reaching 2. So you can claim 2 as a local maximum. Okay. Anyway. Oh, it is no local maximum. Okay. Yeah, it does not have a local maximum. So it is correct. I was thinking it has a local maximum. It is correct. Okay. I hope this is understood. It has a local maximum.